Hello again. In this video, we're going to be talking about how C# is broadly organized into statements, methods, classes, namespaces. We're going to be looking at an issue of scope, and also we're going to be, when we push up on the keyboard, it's going to print out our variable, our guess variable of 500. So let's jump in and make a bit more magic. We're in our script here. I'm going to do a quick recap of our game mechanics. Scroll down the bottom and give myself some white space. I've got my pen tool here. We're asking the player to choose between 1000 and 1, somewhere in that range. We'll say, for example, the player's chosen 687 as their number. I think that's a pretty cool number. And our starting point is to say, well, is it 500? We take right in the middle of those two values. Is it 500? Which is 1000 plus 1 divided by 2. And technically that would give us 500 and a half. And we have to round it down, but that will give us 500. From here, the player's going to say, well, no, my number is higher than that, which in which case we know the maximum is still 1000. This was our max of 1000, and this was our min of 1. Our max is still 1000, but what is our minimum now? Well, our minimum is the same as our guess. Our guess was 500. Now we can say that our minimum is 500, or we can say that our minimum equals guess. And we can assign a variable as another variable. So if we were to say guess as a variable equals 500, now we're to say min equals guess, that's another way of saying min equals 500. Okay. And then now we're going to take the midpoint between those two, so it'll be 1000 plus 500 divided by 2 is going to equal 750, which means our guess is going to equal 750. And we say to the player, is it higher or lower? The player's going to say, well, that's higher than my number. You need to guess lower. That's great. In which case, our new range, 750, becomes our new maximum, and our minimum is 500. And then we take a guess from there as well. So we're taking a guess, we're redefining either the minimum or the maximum, and then we're having another guess, and then we're redefining the minimum and the maximum, and so on. If we go into our start method here, underneath int min equals 1, let's create a new variable, which is guess. So int guess equals 500. We'll start it at 500. We'll get a bit more sophisticated soon with our 1000 plus 1 divided by 2, but for now we'll just put it in as our starting guess. You can see that Visual Studio is saying, oh, you haven't used this yet. That's great. We've only just created it. We're going to come down into our update method. This is where we want to use it. If the player hits the up arrow, they're saying that their number is higher than the number we chose, which means that our minimum is now, oh, undo that. Sometimes autocomplete's a little bit crazy. Minimum equals guess. We can define a variable as another variable. So this variable up here is being defined as 500. Therefore, when we define min as guess, min takes on 500 as its value. The problem we're seeing is a whole bunch of red squiggly lines, and that's a lot of the topic for this lecture, for this conversation. If we mouse over it, the name min does not exist in the current context. Why is that? Well, it's because it's out of scope. And I'm going to show you a couple of things here, a couple of slides as well to make this super clear. I've zoomed out a little bit. I'll do a little bit more scratching on the screen again to show you context. So the code blocks that we talked about in the previous video are also a definition for scope. So you see our curly bracket here, or curly brace, and curly brace there. Within our start method, anything we declare, so we're declaring and initializing these three variables, can only be used as a variable, can only be used in the start method. Update will have no knowledge of it. So down here we have update. It is its own method with its curly braces in here. That's the code block. And it can't see, it can't access, it has no way of accessing those particular variables because it's out of scope. Let me give you a diagram on this to make it super clear. I'm going to go a little bit slow on this to really have it sink in and make it super clear. Use an analogy of Russian dolls. So you've got the big doll, and inside that sits the littler doll and the littler doll and the littler doll, and they can all be grouped together as this cluster. So we can look at our code as statements, statement A, statement B. Jumping back over here, we've got these statements under debug. We've got these statements, our if statement, and then within that we've got our debug statement. So we've got a bunch of statements, statement A, statement B. They're grouped into methods or functions. We use the word method and the word function interchangeably. For all intents and purposes, they are the same thing for what we're doing. And our methods are grouped into a class. We can see back in our script here, the class, right up at the very top, public class. Our class is number wizard. That means at this level, everything within here is part of the class. Or it's probably cleaner if I draw it over here, isn't it? Where we can see it along our line. This is all part of the class. If something was declared in our class, it could then be used in all the methods. And our final grouping, our classes, oops, wrong way. Our classes are grouped into namespaces. And up the top here, we can see using. When we say using, that's using particular namespace. Our namespace is Unity Engine, and that's another way of grouping all of our content in here into a particular namespace. We'll be talking about namespaces more in later videos. For now, we're focusing on this level of class, method, and statement. Let's build upon this and understand about our scope issue at the moment. We have our class, number wizard. Within our class, we have start, our start method, and our update method. If we declare a variable within start, say we're declaring variable A and variable B within start, then those variables are not accessible within update. If we declare a variable C within update, it's not accessible within start. If we declare a variable D in our class, so not within start, not within update, but within our class level, then it can be accessible in both start and in update and any of the other methods that we have within our class. And this variable declared at the class level is called an instance variable because it's available to this entire instance or this entire class. And you might say to yourself, well, why not just put all of our variables up there? That seems to be better. There's a great reason, which is to do with the organization of our code and to keep our code as compartmentalized as possible. If we allow ourselves to access anything at any time, anywhere, then it opens our whole code up to accidental mistakes and things that we just don't plan on, and mostly it makes it difficult to debug. If something's not going right, we can look in at start and say, I know that the only place that these variables are being used, changed, manipulated, modified is within start. As soon as we move it up a level, then we have to look in more places to find what's going on. So it's a way to keep things grouped and organized and tidy and to protect ourselves from some accidents that might happen within our code. Let's jump back over into our script here, zoom in a little bit more so we can see what's going on. Back to our problem, we have min that's been used in update but declared in start, which is not possible. All we need to do is grab these three variables that we're declaring in start, cut them, Control X, up to the top of our script, underneath class, but above where we've got our start method. Give myself a couple of lines in here and paste those variables in. So we've got int max, int min, and int guess all being declared and initialized because we've given them a value at the class level. So these now can be used in any of our methods within the class. I'll tidy up our start method here. Back down, you can see that the red squiggly lines have gone away, which is excellent. And as a last step, let's just print out our guess. So debug.log, open brackets, guess. Semicolon, if we hit save on that, back over into Unity, click on play, we can see it prints two things, up arrow key was pressed, and 500. Excellent. If we keep pushing it, you see the numbers going up over here. It keeps guessing 500 over and over and over. I've got a really simple challenge for you just to complete one other step of this, and you've probably guessed it already, is to, if the number is lower, assign max equals guess. And print out of the console our new guess if the number is lower. So pause the video now. Pretty simple step. Just replicate what we've done in min. Do that for max, and I'll see you back here in a moment. Right, so pretty straightforward. We will say max equals guess in the instance that the player said the down arrow was pushed. And we'll just, again, log out debug.log guess to make sure that this is working. Back over to Unity, click on play, and if we click on the down arrow, then it says 500 as well, up arrow 500. Okay, so really not anything of a game at the moment, but we've created the foundation in terms of having our guess variable. We've talked about scope, understanding now that we need to be declaring our variables at this class level if we wish to use them in start and in update. And in our next video, we'll get more detailed in terms of properly calculating what the guess is so that we get more of a game in our game flow here. Okay, see you in the next video.